Hello, let's look at the electricity, and this is a diagram that shows a circuit with 4 resistor and shows a 2 ammeter in a circuit and EMF of 9 volt and a 5 volt of the volt shows the voltage between 2 ohm and 10 ohm resistor. So we're given a question like this: says calculate the total resistance. The total resistance, you have to calculate the resistance in the parallel and combine with the resistance in the series. So to do that, let's start by the one in the series. So for the resistors in parallel, not in series, in parallel we have resistor, the R12 multiplied by the R20 divided by the R12 plus the R20. Then this one will give us the resistor of them. So adding these two, will have something like 12 multiplying by 20, all divided by the sum of the two, which is 12 plus 20. And then multiplying the two, you'll find that it's 240. And then adding the 2 is 32. Then dividing this one, we'll have 7.5 ohms. So this is the resistor in parallel. So we're looking at the resistor in parallel like this. This is the resistor in parallel. Then we have also the one in series. So this resistor, now they are added, they are one resistor. So when they are added, you have now a resistor of 7.5 ohm and the rest of the resistor, which is 2 ohm and 8 ohms. So continuing with the total resistor, we'll calculate the total resistor. That means we'll add the resistors in series plus the resistor which were in parallel. So adding the two resistor, you'll have 2 plus 8, then plus the 7.5 ohm resistor, and then adding all of them, you will find that is 2 plus 8 is 10 plus 7.5 is 17.5 ohm. So this is the resistor in parallel, and then we're done with the first question. Now they asking us the reading on A1. So they are looking for the current here that passes here. The current here that passes here is the total current in a circuit. So we have to calculate the total resistance, and then you get the total voltage. But because here we are given the 5 voltage, which will make it simpler, we can add the 2 resistor here, and then using the 5 voltage between the 2 resistors, because these resistors are in series. When the resistor in series, the current in series, you will find it from the 2 resistor in series. So let's look at the current. So we have something like this: adding the 2 resistor which is in series, which is 8 and 2, we have 2 plus 8. Then when add the 2 resistor, we have 10 ohms, then 10 ohms, and then you have to find the total current. What is the total current? The total current, you have to use the total okay, because we are given the voltage on the 2 resistor, it can help us to find the current here. Let's say the voltage in the series resistor. So we have 5 here because it's given is 5 ohms, and then adding the two resistor, which is 10 ohms. So the current here is 0.5 amperes. So this is the current that it's on A1, so 0.5 amperes. So let's go to the next question. The next question says the internal resistance of the cell. So the internal resistance of the cell, we have to use the equation of the internal resistor, which is the EMF equals to the total current multiplied by the total resistance in the series plus the internal resistance. Making the internal resistance equation of the formula, will divide both sides by all the sides. Okay, we'll take the current outside. I have something like this. First of all, making the internal resistance the subject of the formula, we take the current is the same thing, take it as a common factor. We have something like this, then dividing both sides by a current. The current cancel this current, and then we'll be left by EMF divided by the current, and then this side left by a total resistance in the circuit plus the internal resistance. So taking R to the other side, the total resistance, will have EMF divided by a current. Taking R to the other side, to have negative R, and then what we have here, EMF, which is 9, and the current is 0.5 minus the total resistance, which is 17.5. Okay, having this thing, so we have something like 0.5 divided 9 divided by 0.5 is like 9/5. Taking 10 to the top, we have something like 5. Then multiplying by 10 will be 90 divided by 5, 17. So how many times does 5 goes here? It's like on 50 there are 10, on 40 there are 8. So 10 plus 8, you have something like 10 plus 8 is 18. So that means we have 10, we have 0.5 ohm as our internal resistor. And then from here we got our internal resistor. And the next question says the reading on A2. So the reading on A2 here is A2 is the current with between the current in one of the parallel resistor. So the parallel resistor, we can use the current divider rule, which says you can say the total current, that the current that you are looking for, which is I12, and then say to the biggest resistor, which is opposite to the resistor that you are looking for, is 20, and then all divided by the sum of the total resistors in parallel, and then multiply by the total current. This is a current divider rule, and then we'll use put 20 here. The total resistor in parallel is 32. No, it's no, the sum of the total resistor, not the sum of the total resistor, the sum of them. So we have something like R12 plus R20 multiplied by I total. So we'll take 20, 12 plus 20 multiplied by the total current, which is 0.5, and then we have something like 20, and then at the bottom is 32 multiplied by 0.5. Then 0.5 is the same as 10/5. So which is 5/10, 10/5. So this is 10, so we cancel the 0, and then we left with 1, so in the bottom. So 2 times 5 is 10 all over 32. So 2 goes how many times here? 5. Here it's 15 plus 1 is 16, so it goes 16 times. And then simplifying this, and you simplify this, 5 divided by 16, what is it? So 16 goes how many times in 5? We have something like 5 is 0.315, 0.3125. So when we check the other one, okay, this is the current that we'll find on the I12, the current that it will be an A2. will be 0 comma. So let's try this current divider rule to see if, because the Ohm's law says the current in parallel, it divides itself. So if the total here is 0 comma 5, when it divided according to the ratios. The ratio means if here the resistor is lower than the other one, this side there will be higher current because it's low, and then this side there will be lower current because the resistor is high, and it will divide according to the ratio. So that's why we have a current divider rule, so which would say now it's 12. So we have to see to prove that the rule, is it true or not. So let's try and see. So yeah, you have to put 12 and this, and then we multiply by the total current, which is 0 comma 5, because the total current that comes from here is the current that comes here as well, because it's in series. When they come back here, they sum again, they divide there, and then when they come back, they sum again, they add up. So the current here is the same as the current that is here, and that's going that direction. It's the same, but in between these two resistors in parallel is not the same. So here A2 is not the same as A1 because it divides when it comes through here, but when it comes back, combine again. So let's see what will be the current here. Adding this two, and we'll have 32 on the bottom. Doing the same thing, 0 comma 5 is the same as 5 over 10. And say 5 times 12 is 60. 10 times, that's 10 times 32 is 320, so the 0 will cancel out. Now we'll have 6 over 32. So now how many times does 2 goes here? Here it's 3 times, and here it's, so using the calculator, we find that it's 0 comma 1875 amperes. So let's see, according to Ohm's law, tells us that the current here, they divide in a parallel. So we have to say total current and the sum of the total in here must give us the total current if we add them, both of them. So let's see, here we end up, let's take the fraction, which might be simple. This is the 21, so we have 5 over 6 for the 12, 5 over 16 plus, here is 3 over 16, 3 over 16. Then adding this 2, because the denominator is the same, just take 1, and then adding this 2, you'll have something like 8. So what is 8 over 16? 8 over 16 is, now you have how many? how many? Okay, 8. Okay, 8 goes how many times on 8 is 1 times 116 is 2 times, so it's the same as 0, 0.2, 0, 0.5. So I mean this can be proven. If you are not sure in exam, you can prove this thing that you have calculated the correct current by calculating to the other side of your resistor to see if they add up to a total, because the current here and the current here must be the same because they are in series, so they go and divide in the parallel, and then only the current divide in the parallel, the voltage is the same according to the laws that we have learned. So thank you for watching. See you on the next video.